Good evening. Welcome to Matlab Masterclass Series Day 13. So before we go into the session, first I would like to thank IIT Mumbai for their cooperation and for their support for this event. I would also like to thank you for your participation and thank you for your commitments and thanks for coming today on Sunday. And I warmly welcome you once again for this workshop. So today is Day 13, image segmentation using Matlab. So far we have covered up some basics on image processing and computer vision, fuzzy logic and machine learning, deep learning. So far we have covered up. So today's topic is on segmentation. Again, segmentation is a vast topic, so we are going to cover up only basics today. And image segmentation is also plays a major role on image processing as well as on AI. Okay, so today topic, let us go into the topic today. What is image segmentation? So image segmentation, it's like partition the image into multiple segments. It's called image segmentation. It depends upon the context. Sometimes segmentation is needed for localization. Sometimes, for example, if you take medical image processing, segmentation is done on tumor to extract the size, shape, as well as the area of the tumor, so that you could better analyze whether the tumor is benign or malign. So segmentation will give you more meaningful data from an image. So that's the advantage of segmentation. So even if you take this, we did this live example, like I have a green mat on my bag. Which I do a background subtraction and I extract my foreground and I superimposed on the screen cap on the image which I get from the screen capture software. Okay, and then finally it was transferred to the cloud. So similarly, so this process itself has a segmentation technique. So my image has been segmented and it has been superimposed on the desktop in the screen capture software. So this is a type of video segmentation. So segmentation, like it has various applications are there in segmentation. So we'll go one by one. So segmentation is based on kind of grayscale. Like you can do segmentation on grayscale images. Like it may be based on thresholding or multi-thresholding like that. So segmentation can also be done on grayscale images. And you could also segmentation based on texture. Texture is something like repetitive patterns. For example, you take mosaic or tiles. So they have a repetitive pattern. So you could do segmentation based on textures. So that is texture based segmentation. And it could be like, if you take in this example zebra, that the pattern is the texture pattern you could segment and you could extract the object from the image. So that is texture based segmentation. And another is color based segmentation. So you could do segmentation based on color. For example, in this case, like to segment the apples and to count the apples or like that. So segmentation can also be done based on color using color as a threshold, like the RGB values, red, green and blue values as a threshold. You could do segmentation. And segmentation based on motion. Segmentation based on motion. Like if you see in this example, only the moving objects will be segmented. This is used for like surveillance, video surveillance system, where you want to get an alert whenever a motion is directed, or you want like a pedestrian detection system where you want to detect, or the vehicle counting or vehicle monitoring like that. So when segmentation is done based on the motion, like using the optical flow. So this type of technique is called a motion based segmentation, like segmentation based on motion. You could do segmentation. And this semantic segmentation, I'll show you an example for semantic segmentation for strawberry harvest. So this is a video by a company called Agrobot, like where they use semantic segmentation and instant segmentation for harvesting strawberries based on color. Okay, so if you check in this video, so they used a deep learning technique as well as segmentation technique to pick the strawberries and to harvest. So they use a NVIDIA development board, as well as they use deep learning and segmentation techniques. So instant segmentation, they used to identify based on color, like whether the strawberry can be harvested or not. So for that they use instant segmentation.
This being such a delicate and precise process, how can a machine hope to replicate what humans have mastered in generations? First, they are scanning with
So they are identifying the colors.
this intelligence is trying to indicate where the right strawberry with stay on the strawberry, because we first start the ongoing to select the cutting point and then we move the robotic arm to this point. But we first grab the strawberry and select the important we don't pass the strawberry. It's not a question about bruising it because we make finger direct as delegated as human. It's a question of try out diseases. So as less contact we have with the plants or with the fruit, higher quality product.
So this is a good example of using image processing and deep learning for an agriculture field. As like the system should do what humans can do on the field, and they used to replicate the humans.
So naturally, I wondered, how could Agrobot possibly keep up with all of the variations in cutting crop? The answer is AI.
So they use a deep learning convolution neural network.
Agrobot system uses semantic segmentation, which relies on a convolutional neural network to classify each pixel in one image as either belonging to the strawberry class or not. However, the strawberry is overlapping the image when semantic segmentation is semantic. Agrobot is looking at extending their system to instance.
So in this overlapping case, like they use instant segmentation to identify the types.
The system uses unique bounding boxes to generate roughly instant segmentation. Areas where bounding boxes overlap can be further refined by weighing every pixel against a likelihood value of each of the overlapping instances. The result allows the system to more accurately assess individual strawberries' performance.
Sería imposible hacer lo que hoy en día hacemos si no hubiéramos tenido la evolución de la capacidad de computación de los sistemas completos. Siempre hemos utilizado CPU de pila porque sería imposible que se
So they have used an NVIDIA processor like Jetson Nano and TX1 and TX2. We have a session on semantic segmentation on September 30, and we also have a session on NVIDIA Jetson Nano to how to use Matlab deep learning algorithms on Jetson Nano on around September 24 or 23. I'm not sure. You could check out the dates.
These are all fascinating and incredible.
So this is an example for semantic segmentation using deep learning. So the next is on depth-based segmentation, like where you use stereo cameras and you extract the depth maps, and you could segment the objects. So this is used for autonomous robots to create a map inside the room and to create to locate the objects for obstacle avoidance. They could locate the objects, and they could create a map, and they could they could identify the position, and they could follow the map for path following and as well as path planning. So this is one example. So which a robot has a stereo camera and which constructs the depth maps. So it takes the stereo camera is nothing but it will have two cameras, and you could get the exact distance of the objects, as well as you could get the depth maps. So it is an optional for LiDAR, like you could use stereo camera instead of LiDAR. It will do the same thing, and it could be used for autonomous robot navigation, as well as like path following, and you could do path following or a path replanning also you could do. the path planning and path replanning is not image processing. It's a different algorithm. Like there are algorithms like A star algorithms, which we are covering up in a topic called SLAM, self-localization and mapping. That is on September 29th. I think it is on September 29th and 28th. Okay, so this is an example for segmentation based on depth. So other segmentation techniques, like I have mentioned only few algorithms, but if you take a list, I'm sure there may be around more than 200 to 500 types of algorithms on segmentation alone, like segmentation based on thresholding, segmentation based on multi-thread. It depends upon the context it depends upon the application. For example, if you take angiograms, if you take angiogram images, like to segment the blood cells and blood cells, as well as nerves, or you could go with the level set kind of technique, or Snake's algorithm. Or if you take a tumor, in that case you could go for a clustering based technique, like a fuzzy C-means or K-means kind of algorithm, where you could extract the tumor and you could get the volume of the tumor and the size and shape of the tumor, everything. So whereas the background subtraction kind of thing, it's like different, like background subtraction segmentation for segmenting foreground, to go with foreground segmentation, like it's based on the motion. Or if you take a normal road, like a motion, like traffic monitoring kind of thing, then you could go with motion based segmentation. So there are a lot of algorithms out there, so you have to choose. One algorithm will not fit for all applications, so you have to choose a correct segmentation algorithm for your application. So we are going to cover up some basic algorithms today. And Matlab also have a tool to generate code for segmentation. There's an app called Image Segmenter, where it generates code. That is also covered today. So how to generate a segmentation code. So no need to write the code. So you could generate the code and you could use it. You could make use it in your project. For example, like this is used whenever you need to segment like more than 10,000 images to generate ground truth. So we have an app called Ground Truth Labeler app, but that is manual process. So for example, if you want to segment 1,000 images, then going with the ground truth labeler, for like it will take 1 minute for one image, so 1,000 minutes it will take. So it will take 5 days or 7 days to complete the process. Whereas you could use the image segmenter app, and you could create a program for that segmentation. Then you could apply the program to all the images, 1,000 images, which you could done within 10 to 15 minutes of time. So that app we are going to see today. So let us go to the Matlab. So today's lessons, like we are going to cover up a segmentation based on color. First, it's a simple technique, how to go color based segmentation technique. Then second is segmentation, how to segment the image by using thresholding by an image segmenter app. And again, we'll be using the color based graph cut segmentation. We'll be going through graph cut segmentation, how to segment a color images by using graph cut segmentation using image segmenter app. Okay, these three things we will be covering up today. So first, for segmentation of color, I will explain you the code first and the process first. Then we can go to the Matlab and we can go in detail. Okay. So if you check in this program, the first thing is UI get file. UI get file is used to read the image from the current working folder, and strcat is for string concatenation of path name and file name. So to read the image, so A equal to imread will read the input image, and size of A is used to get the it will give you the number of rows and number of columns and number of planes. If it is a color image, the P equal to 3. If grayscale, if P equal to 1. Okay. The first process is to split the planes. You have to split the red plane, green plane and blue plane. You could also use a command called imsplit, but only Matlab latest version have the command of imsplit. So the previous version don't have the command called imsplit. So I have split the command like using R equal to pick of 1. It will state that it's a first plane. G equal to pick, it's a green plane. So blue is the third plane. So first I have read the image and I split the planes. Okay. Once I split the plane, then you have to go for threshold based on color. For example, red pixel. To identify the red pixel, you have two. Red will have the majority value, and green and blue will have the zeros, and blue and will have the zeros and values. Okay. So to identify the background, here we are identifying that white color. White color will be red will be greater than 250, and green is greater than 250, and blue is greater than 250. You will be getting a white color background. So that color we are segmenting by using a simple for loop. So we are letting a if loop to segment the color. So initially we are initializing the mask as zeros. Mask equal to zeros of R comma C will load the size. It will take the size of the image and it will load the mask as zeros. And this program will load the mask only when you have the particular color. So here you could choose whatever the color you want. You could use IM pixel info to get the color information, and you could load the color here. So it's a type of manual kind of thing, manual thresholding. So you could load the threshold, and then you could get the binary. Then here I am going to get the threshold color based black color is on thresholding. Like if red is less than 50 and green is less than 50 and blue is less than 50, I assume that the color is black, and I run a program. I am loading mask 0. So mask is the first mask is to identify the white color, and second mask is to identify the black color on the image. Okay. So on fourth step is the boundary labeling process, where we are labeling the boundary. BW label stands for bounding the label. So it will group the close connected components. So it will give you close connected components, and BW boundaries will give you the exact boundaries of the white color, like of the closely connected components. Okay. Then after that we are plotting the boundary. So we are taking this and we are plotting the boundary. We are using a plot command to plot the boundary. So this is the program. We'll go to the MATLAB and we will check the program. Okay. So I'm going to MATLAB now. So I'm creating a folder. Okay. I'm creating a folder. I'm going to copy this 2 image to that folder. The first thing is to change the path. Copy this path. Open MATLAB. So it's taking some time to open the MATLAB. Okay. So in this image, we are going to segment this black color. So we are getting a mask for this white and this for black, and we are going to plot this. Okay. So I'm going to close. First, change the path. CD. Okay, single quote space the path. You could also change the path by clicking the folder here, right click and paste. Okay. So the path has been changed now. So I'm going to ensure the font size. So font size is 24 and font size is again 24. Okay. So type edit to open an editor window, and I'm going to read this file ls help UI get file to get the file. Okay. Before that, I am going to clear the variable as well as clear the screen. Okay. So this is to choose an input image. This is to choose the input image, and I'm going to give file name equal to strcat of string concatenation of both path name and the file name. Okay, to get the file name. Here I'm going to read the image. IM read is a command which is used to read the image, I'm reading the image. I'm going to display the image. Figure show of A. Okay, I'm displaying this image. Save the program. EX1. Okay, editor, go for editor, run the program. So run the program. This okay. So this is the image which we have read. Okay, this is the image which we have read. Now I'm going to find the size of the image equal to size of this image. This will calculate the size of the image. Okay, now I'm going to get the red component of this image. So this will get the red and this will get the green component of the image. I'm loading this colon comma colon denotes that it will take all rows and all columns. Okay, blue equal to AF. So this is plain separation is done. Save the program. Okay, run the program. So if you check here, red, green and blue, I got those values, red, green and blue here, red plane, green plane and blue plane. Okay, 804 into 803. Now I'm going to run a for loop for I equal to 1 to R and for j equal to 1 to I equal to C end. Okay, and here I'm going to run a if loop. Before that I'm going to allocate mask white, like I'm going to give mask white equal to zeros of R comma C. Okay, it will allocate zeros. If red of I comma j. Okay, if red of I comma j is greater than 250. Okay, and green of I comma j is greater than 250. Okay, and blue is greater than 250. Okay, end, closes end. So now if it is there, then you put this mask white of I comma j equals 255. Okay, now check the program figure. You have to get figure of show of mask white. Run the program. So choose this program. Okay, this is the mask you have obtained for this image. Okay, now I'm going to copy the same for loop. Okay, this is the for loop. I'm going to copy the same thing and I'm going to paste it here. It's less than 50. Okay, instead of greater than, I'm going to put less than 50. Less than 50. Okay, so I'm going to this as allocate this as mask black. Okay, mask black equal to zeros of this will allocate only zeros. For example, I will show you how what A equal to zeros of 3,3 will allocate only 3 will allocate only a 3 × 3 matrix with zeros. Okay, so mask black we have obtained. Here we are using mask black equal to 255. Okay, so I'm going to show this as mask black. Run the program. Okay, you got this. Okay, now I'm going to num equal to boundary label, okay, boundary label of mask black and BW boundaries. You just type help BW boundaries. Okay, you got a code here. Copy this code. Okay, let me check whether it is working or not. Disk of set, just to keep a breakpoint. Okay, just to keep a breakpoint, I have mentioned this, and I want to check whether it is working or not. Just I want to display figure M show of B. Let me check what B is. Okay, it's an array, so you have to pass this mask black here. Okay, so boundaries, you type this help BW boundaries, help BW boundaries. You get an sample code here. Okay, for k equal to 1 to n, end. Okay, take this command, copy this code, paste. Before that, display figure im show of the original image A, im show of A, hold on. Okay, so run the code, run the program. So I'm going to choose this and right click evaluate selection. So 12, once again, if non-return of 0, okay, you can take this length of B. Okay, close all, right click and evaluate selection. This is K. So if you check this program, I will explain you the code one more time. Okay. First read an image. UI get file is used to get the file from the current working folder. strcat is for concatenation of path name and file name, and again you are reading this image. ImShow is used for display. Size is used to get the size of the image, how many number of rows and how many number of columns, whether it is a color or not. Then you are going to split red, green and blue, red plane, green plane and blue plane, and mask white and mask black, like you are going to allocate zeros, mask white zeros of R, C and mask black of zeros of R, C. Okay. Then for I equal to 1 to R and for j equal to 1 to C, like we are running a for loop where we are greater than 250, we are allocating this as 255. Okay, for identifying the white color, and this is to identify the black color. Okay, because in this image we have this region is white and this region is black. Okay, we are identifying this two color. For red less than 50, green less than 50 and blue less than 50. I'm sure of black. And boundary label, this boundary label is not needed now, so you could use BW boundaries to plot of mask black. Okay, BLNA, this will give, and this for this code, this is to use to plot. You could type help BW boundaries and you could change. Okay, this is to length of B. This it will take only the boundaries of the closed connected components. And plot is used to plot the command, and G is used to green. If it is red, it will give you the red. Okay, so run the program, choose this image. If you check now, so if you check here, you got the two red color regions. Okay, this will give you the line width. This is segmentation based on color. Okay, segmentation based on color. So the next example is on image segmenter app. So I'm opening Matlab here, dbQt for debugging mode. Okay, you just go for apps, click this apps, go for search for image segmenter. Image segmenter. Image segmenter. Okay, here is the app. So click this app. This segmenter is used to create a segmentation program. You could load the image here. You could from workspace or from file. I'm going to load the image from file. So I'm going to choose an image first. First I'm going to copy an image over here. So I'm going to copy this rows and this black and white, paste it here. Okay, load the image from file. So I'm going to choose this rows. Okay, rows.jpg. This is the image, and this is used to load the image. So you could, if you want to include texture features, you could click this button, include texture features. This threshold is used only for black and white images, grayscale images. And graph cut, if you choose this one, this is the algorithm. You have graph cut algorithm, auto cut, auto cluster. You could also find the circles over here. finally create a mask and you could export to the file. So first we will do, first I'm going to choose graph cut here. Okay, once I choose graph cut, I have an option for a foreground segmentation and a background segmentation. Okay, I want to segment only the rows, so the background is this. So click background and you choose this background. Okay, I'm choosing these are all this background. Okay, these are all background. I'm choosing this as background. I don't want this also, so this is background, this is also a background, and this is also a background. Okay, so I'm choosing this as background. Finally, now choose foreground, click foreground and choose, I'm marking this as foreground. Okay, so once you choose this, you get an image. This will mark the foreground. So this is the foreground image. Okay, this is the foreground. Once the process is done, click show binary. Show binary. Create mask. It created the mask. Now you could export the mask or generate function. I'm going to generate function. Now a function called segment images is generated. Okay, I'm going to save this function now. Home, file, save. Put controller save segment image. Now I have saved this program. So if you check this program inside, so MATLAB itself will create a program. It will convert to RGB image to LAB color space. Then like it has show the foreground pixels as well as the background pixels, and it gives output. Now I'm going to type edit to open an editor window. I'm going to read the image. I am read of rows.jpg. Okay, so this is the function which we created from MATLAB. So I'm going to use this function. This is the input image. Okay, now I'm going to open a figure subplot of 1, 3, 1 image show of A. Okay, subplot of 1, 3, 2 image show of the binary mask. Subplot of 1, 3, 3. Okay, image show of the masked image. Example 2. Okay, save the program, go for editor and run the program. Okay, so this is the input image. This is the input image. This is the mask generated from the program, and this is a segmented image. Okay, so we have not done anything. The code has been created by MATLAB. So if you have around 1000 images similar to this, you could create this one and you could generate the code and you could apply the code for your own application. Okay, so now I'm going to show you how to apply this black and white image. How to apply for black and white image. I'm going to open image segmenter app. Okay, now load the image from file, this.png. Okay, so now like you have an option for threshold. Now previously it was not there, now it was there because it's a grayscale image, threshold image. So click threshold. So you have an option for a global threshold, or you have an option for manual threshold and adaptive threshold. I'm going to choose manual threshold. Here I can vary the threshold. See, I'm going to vary. This is okay, this is the threshold. I'm going to choose show binary. Okay, create mask. Again, mask has been created. Now I want to export this as function, so generate function. So since it is black and white, I am mentioning this as black and white here. Save the program, segment image black and white.m. Okay, so if you check now, I'm going to edit. I'm going to type edit to create a program. I'm going to read the black and white image, read of cameraman.tiff. Okay, so copy this one, you pass it to A, and I'm going to copy like figure of subplot of 1 comma 3 comma 1. Okay, show of A. So I'm going to copy this code and paste it 3 times. Okay, so this is BW. This is the masked image. Save the program as example3. Okay, example3. Now if you check segment image, run the program. Okay, but you have not got the output now, so there is a problem in here, like so this is the program, so it is getting a threshold. Okay, so there's a slight change you have to do here. IM complement of binary. Okay, save the program. Now run the program again. Okay, this is the image, this is the segmented image. So I'm going to complement it again so that you will get a better visual over here. Okay, so if you want to image segmented, open this load image from file, choose this one, choose the image, go for threshold, go for segmentation. Okay, I have applied global threshold, create mask, and create mask and like generate function. Okay, this is bound black and white 2. Save the program. Both the name, function name, it should be same. This is 2. Okay, so go this, enter this one segment, you copy the IM complement here. Okay, this is the segmented image. So I am going to figure it in different figures to get a better visualization. Okay, so if you check now, it is segmented. Okay, since the background is also black, it is not visible for you, but the it contains a segmented image. So check. Okay, okay, so this is a segmented image. Okay, segmented image. So with this I will close the session today. So far we have caught up the color image segmentation, and image segmenter app, like how to do segmentation based on image segmenter app and on for grayscale image. Okay, so if you have any doubts, you just comment it on the comment box. For the pro version, you could comment it on learn.pantechsolutions.net. And I once again thank you for coming on Sunday, and thank you for your participation. So meet you on next session. Until then, bye.